The very first episode of this podcast was published July 28th, 2021, so not quite 3 years ago. And it was about cicadas. Now, the reason I chose cicadas for that inaugural episode was because at the time they were making headlines. The 17-year species known as Brood 10 was emerging across parts of the Midwest and eastern United States. And this year, cicadas are making headlines again, thanks to an event that hasn't happened since 1803, when Thomas Jefferson was president. Brood 19, a 13-year species, and Brood 8, a 17-year species, are emerging at the same time. Now, I gotta say, I'm a little jealous that I'm missing the big show right now. I'm an Illinois boy born and raised, and that's where the two broods are overlapping. But I have an aunt in Wisconsin who's been dreading this cicada emergence ever since she found out about it. I sent her some cicada recipes. What more does she want? Now, if you listen to episode 1, I want you to know that I've learned some really cool new things about cicadas, so this is not just a rehashing of that episode. I mean, it is a little, but there's new stuff to learn too. And if you know nothing about cicadas and you didn't listen to episode 1, you might be thinking, what are you talking about? 13-year, 17-year broods? Well, don't worry, I'll explain it all, because in this episode, we're revisiting cicadas. Or are they revisiting us? Well, either way, I'm your host, Tim the Nature Nerd O'Hara, and this is the Dispatches from the Forest podcast. I love cicadas, but I can see why they freak some people out. Sometimes that's because people confuse cicadas with locusts, probably because both sometimes appear in large swarms. But locusts and cicadas are very different. Locusts are a species of grasshopper that can swarm under the right conditions. And a swarm of locusts can be devastating, especially to crops. Cicadas, on the other hand, well, any damage they do is usually minor. The biggest threat from cicadas is getting a headache from all that buzzing. If you're unfamiliar with what is one of the loudest insects on the planet, and that's not exaggeration, let's review. There's a lot of different species of cicadas, over 3,000 worldwide, but they generally come in two flavors, annual cicadas and periodic cicadas. The main difference between them is how long they spend living underground as nymphs before they emerge, and whether or not that emergence coincides with the emergence of millions of their friends. Except for variations in color and slight differences in size, all cicadas take the same basic form. Cicadas are big insects, and they look like little aliens. They're 1 to 2 inches long with prominent wide-set compound eyes and short antennae. Their abdomen is segmented. In females, the abdomen terminates in a large saw-edged ovipositor. In males, the abdomen is largely hollow and used as a resonating chamber, which is how they make so much noise. More on that later, but like I said in episode 1, I think cicadas are the signature sound of summer. Cicadas have membranous wings which can be clear, cloudy, or pigmented depending on the species. The veins in the wings also vary by species and can help with identification. But here's something that I just learned. Cicadas' forewings are super hydrophobic, meaning that they repel water really, really well. Now this is because the wing is covered with microscopic waxy cones, basically blunt spikes that create a water-repellent film. Rain rolls across the surface and in the process removes dirt. In the absence of rain, dew condenses on the wings, and when the droplets coalesce, the cicada will make a small jump to remove the dew and clean its wings. But that's not even the best part. What's really neat is that bacteria landing on the wing surface are torn apart by these nanoscale-sized spikes, making the cicada's wing surface the first known antibacterial biomaterial. How cool is that? Now, once they emerge from underground, both annual and periodic cicadas have the same basic items on their to-do list. First, molt. Second, make a whole bunch of noise to attract a mate. Third, mate. Fourth, for the ladies, lay eggs. And last but not least, die. And they're in a hurry to get through those first 4, because after they emerge, cicadas live less than 8 weeks, assuming something doesn't eat them first. So for both annual and periodic cicadas, most of their lives are spent underground as nymphs, and like I said, the main difference is how long they spend there. Cicada nymphs feed on the juices from plant roots, generally within 2 feet of the surface. During their time underground as nymphs, they go through 5 instar or intermediate stages in their development. With periodic cicadas, the second instar is the one that takes the longest. As they mature, the nymphs might move deeper into the soil to feed on larger roots. When they finally reach that 5th instar, the cicada nymph is ready to emerge. When they're ready to emerge, the nymphs build a tunnel to the surface and wait for the soil temperature to reach a critical value. For periodic cicadas, this is around 65 degrees Fahrenheit, which is 18 degrees Celsius, 8 inches below the surface, so usually around April or May in their range. For annual species, this critical temperature tends to be higher, so they emerge later in the summer, July or August. One of the benefits to this difference is that annual and periodic cicadas don't often encounter each other, reducing the chances of hybridization. Whenever they emerge, the nymph will climb anywhere from a few inches to 100 feet up a vertical surface before checking item number 1, molt, off that to-do list. My kids used to love finding empty cicada nymph exoskeletons clinging to the trees. We collected buckets of them in the summertime. Once they molt, the adult cicadas move to the trees and spend the next 6 days or so waiting for their new exoskeleton to completely harden before they can move on to the next item on their list, making a bunch of noise. And again, time is not on their side, so now they have even less time to accomplish their tasks. Now, it's a common myth that adult cicadas don't eat, but that's not entirely true. Adult cicadas do have sucking mouthparts and will drink tree sap. However, even during a large emergence, their feeding doesn't generally cause any permanent damage. Normally, excess fluid is excreted in a stream of droplets. Okay, yeah, they basically pee it out. But some species, especially desert-dwelling species, are unusual among insects because they can control their body temperature by evaporative cooling, just like sweating for you and me. When their temperature gets over 102 degrees Fahrenheit or 39 Celsius, they suck up excess sap from plants and excrete the excess water out through pores. This lets them reduce their body temperature by nearly 10 degrees Fahrenheit, 5 degrees Celsius. Some non-desert dwelling cicadas can also cool themselves this way, but it's not necessarily as efficiently. Conversely, some species can raise their body temperature by as much as 40 degrees Fahrenheit, 22 Celsius, over the ambient air temperature if the weather is too cool. So let's talk about all that racket that cicadas make. First of all that noise comes from the males, because of course it does, right? But they don't make that sound with vocal cords, and for the most part they don't use stridulation, which is when an animal rubs 2 body parts together to make noise, like crickets rubbing their wings or grasshoppers rubbing a leg against their forewings. Although there are always exceptions, and some cicadas use stridulation in addition to the method I'm about to describe. Instead, cicadas have a special organ called a timbal. Located in the abdomen, the timbal is a corrugated structure of the exoskeleton with membranes that vibrate rapidly to produce sound. Inside the abdomen is a large chamber. It's actually a modified trachea that amplifies the sound. Cicadas also modulate their songs by positioning their abdomen toward or away from whatever surface they're sitting on. Each individual species produces its own distinctive mating songs and acoustic signals, ensuring that the song attracts only species-appropriate mates. For example, here is a scissors grinder cicada. And this is a dog day cicada. Now, interestingly, there are some cicada species in Australia which only have rudimentary timbals in both sexes and don't produce audible airborne sounds. Instead, both sexes make vibrations that are transmitted through the wood of the tree they're on. These species are thought to represent the original state from which other cicada communication evolved. Now, most cicadas are diurnal, calling during the day. In fact, most cicadas call during the hottest part of the day, although there are some that call at dusk and a few nocturnal species. Male cicadas group together to form a chorus, and together they can produce sounds that exceed 100 decibels, which is about as loud as your typical gas-powered lawnmower, and among the loudest insect-produced sounds in the world. Now, only males make the noise, but both sexes have structures called tympana, which are the insect equivalent of ears. Males actually disable their own tympana when calling to prevent damaging their hearing, which is smart because their song is loud enough that if it was singing too close to your ear, it could actually cause permanent hearing loss. In contrast, some smaller species have songs so high in pitch that they're not audible to humans. For the human ear, telling precisely where a cicada song originates from can be hard. The pitch is nearly constant, the sound is continuous to our ears, and cicadas sing in scattered groups. In addition to the mating song, many species have a distinct distress call, usually a broken and erratic sound emitted by the insect when it's seized or panicked. Males alternate bouts of singing with short flights in search of receptive females. Some species also have courtship songs, which are generally quieter and produced after a female has been drawn to the calling song. Receptive female cicadas respond with specifically timed wing flicks. Males also make encounter calls, either during courtship or to maintain their personal space within the chorus itself. Males may mate with more than one female, but females generally only mate once. All right, let's see how we're doing on our checklist. Molt, check. Make a lot of noise, check. Mate, all right, check. Next up, laying eggs. Now, using that saw-like ovipositor I mentioned earlier, the female cuts a V-shaped slit in the bark of young twigs and lays about 20 eggs. She'll repeat this process many more times, laying about 600 eggs in total. Now, while these twigs might wither and droop, the damage done by cicadas to a mature tree is both minor and temporary, even during a large emergence like we're seeing now. Now, it's true that smaller saplings or newly transplanted trees can suffer more damage, but they can also be protected with netting. These emergences aren't really a surprise. The eggs hatch in 6 to 10 weeks, the nymphs drop to the ground, burrow into the soil, and the cycle starts over. Adults can now move on to the final item on their checklist, dying. Like I mentioned earlier, the time from emerging and their final molt to their final breath spans less than 2 months. Now, periodic cicadas, just through sheer numbers, do have an impact on other species. For example, in the year before a brood emergence, tree growth declines because of the increased feeding on the root systems by the growing nymphs. Moles do well in the year before a brood emergence because they eat the nymphs, but mole populations decline the year after a brood emergence because of the decrease in this food supply. Wild turkeys benefit from brood emergence, gaining nutrition by eating the adults on the ground at the end of their life cycle. On the other hand, the temporary damage from cicada egg laying may reduce the production of nuts, which may have a slight negative impact on squirrel populations. In addition to turkeys, plenty of other animals eat cicadas when they're available. Birds, snakes, rodents, possums, even fish, just to name a few. I mean, basically, if it eats insects, cicada is just another item on the menu. And if they don't get eaten, all those cicada bodies return nutrients to the soil, and the tunnels created from the nymphs emerging lets water and air into the soil, ultimately improving the health of the forest. Now, here in the U.S., each of the lower 48 states has at least 4 different species of annual cicadas. California has the most, a whopping 80 different species. Annual cicadas spend somewhere between 2 and 5 years underground as nymphs, and unlike their periodic cousins, their development isn't synchronized, so some emerge every year. Periodic cicadas, on the other hand, spend either 13 or 17 years underground, and their development is generally synchronized, so they all emerge mostly at the same time. Occasionally, some emerge early, as much as 4 years early, which is known as straggling. But it's highly unlikely that these stragglers will find a mate, since most of their friends are still underground. Periodic cicada species are designated as broods and given a number. There are 12 broods of 17-year cicadas and 3 broods of 13-year cicadas. Now, this type of lifestyle, spending a long time in the larval stage and a short time as an adult, is not uncommon in the insect world. Lightning bug larvae spend several years underground before emerging, and dragonflies spend most of their lives, up to 5 years, in the water as nymphs. Like cicadas, the adult form of dragonflies and lightning bugs is brief. But even among insects with a similar life cycle, 13 years and 17 years is an exceptionally long time. So the question is, what's the benefit to such a drawn-out developmental span? And of course, nobody really knows for sure, but there are theories. Some entomologists think that this strategy evolved as a sort of defense mechanism, an insurance policy, if you will, against predators. It's known as predator satiation. Emerging in such massive numbers, over 1.5 million in some areas, means that most of the population is likely to live long enough to mate and reproduce, even if a whole bunch of them get eaten. Again, this is a strategy used by a lot of plants and animals. Bullfrogs lay 20,000 eggs at a time, and cattails produce 250,000 seeds per seed head. If you produce a massive number of offspring, a good number of them are likely to survive long enough to reproduce themselves, ensuring the continuation of the species. Other theories about the 13-year and 17-year time frames center on the fact that these are both prime numbers. One theory suggests that because they're prime numbers, it helps keep predator populations from syncing their own reproductive cycles with that of the cicada, which helps the cicada avoid facing a larger number of predators when they do emerge. Another theory is that it prevents hybridization between cicada species. I touched on this a little earlier. Periodic cicadas emerge earlier in the year than annual species, so they're gone or at least done mating by the time annual cicadas emerge, and the timing of different periodic broods means that they only encounter each other once every couple of hundred years, like what we're seeing now. Okay, there are two other things that go hand in hand with cicadas that I want to tell you about: cicada killer wasps and the massive spora fungus. Now, while lots of animals will eat cicadas if they're available, there's only one that targets cicadas specifically, the cicada killer wasp. But it's not as food, at least not for itself. Adult cicada killers eat nectar and sap, not cicadas. So what's the deal? Sometimes called a cicada hawk or a sand hornet, even though it's not a hornet, in appearance, the cicada killer wasp is a fearsome-looking thing. I mean, it's not only a wasp, but it's a big wasp. They get up to about 2 inches long, making them one of the biggest wasps in the eastern United States. But, that said, they differ from other wasps in some very important ways. Cicada killers are solitary. They don't group together socially to create a swarm like, say, paper wasps or yellow jackets. Males are sometimes seen in groups battling each other for breeding rights, and females sometimes share a burrow, but cicada killers are not defensive. Females only use their sting to paralyze their prey, not to defend their nest. And males don't even have a stinger, so they couldn't hurt you even if they wanted to. And while females can sting you, the only reason they would is if you try to grab them, or if you accidentally stepped on one, or if it somehow got caught in your clothes. So really, in spite of their fearsome looks and name, unless you're a cicada, you really don't have much to fear from the cicada killer wasp. Cicada killers are ground nesting. The female digs a burrow by dislodging soil with her jaws and then pushing it out with her hind legs, which have a special spine just for pushing dirt. These burrows average about 1/2 inch in diameter and 10 to 20 inches deep. After digging the burrow, the female wasp goes out hunting for cicadas. She catches a cicada, usually in flight, and delivers a sting to paralyze it. Then she carries it back to the burrow. Now, cicadas can weigh twice as much as the wasp, so a lot of times you'll see the wasp carrying the cicada up a tree or something else to get altitude for the flight back. After returning with her prize, the wasp will put the cicada in a cell in the burrow and deposit an egg on it. Female wasps grow to be about twice the size of males, so male eggs are deposited on one cicada, but female eggs might have 2 or even 3 cicadas put in the cell with them. Honestly, I think the most fascinating part of that nugget of information is that the wasp knows the sex of the egg she's laying. Once the egg is deposited, the female closes the cell with dirt and digs a new one. Eventually, she'll dig 10 or more cells. Now, it only takes a couple of days for the eggs to hatch, and the larvae, called a grub, feed on the cicada. The larvae mature in about 2 weeks, build a cocoon, and overwinter in the burrow at this stage of development. In the spring, they'll pupate, turning into adults that will emerge in late June or early July. Cicada killer wasps produce only one generation per year, and adults don't overwinter. So just like their prey, once they emerge, they're kind of on a tight schedule. Okay, last thing I want to talk about is Massospora, or cicada zombie butt fungus. Massospora is a parasitic fungus that infects about 5% of cicadas. Each species of cicada has a corresponding Massospora fungus. So the fungus that infects periodic cicadas will lay dormant in the soil for either 13 or 17 years, patiently waiting for a brood emergence. Initial or stage 1 infection happens when the nymphs dig their way to the surface and encounter the waiting spores. The fungus then grows inside the cicada's abdomen, rendering them infertile and eventually causing the rear part of their abdomen to fall off. The white chalky plug that's left is the fungus producing spores, which is why my entomologist friend refers to them as flying salt shakers of death. The fungus produces two compounds, cathinone, which is an amphetamine, and psilocybin, which is the same hallucinogen found in magic mushrooms. So you've got a bunch of cicadas hopped up on amphetamines and also tripping balls. Now, like I said in episode 1, before anyone gets any funny ideas and does something stupid, the amount of these compounds found in an infected cicada is very small. It's more than enough to get the cicada high, but for a person, it's not even close. I mean, cicadas are edible, but they're not edibles, if you know what I mean. In the cicada, the combination of these compounds makes them go into a mating frenzy, attempting to mate uncontrollably, even to the extent of males mimicking the wing flicks of females to lure other males in, thus spreading the spores of the fungus. Cicadas that are passed the spores by other cicadas contract what's called stage 2 infection. In stage 2 infection, the fungus produces a different type of spores. These spores are called resting spores. They have thicker walls and are not directly infectious to adult cicadas. Instead, these are the spores that will lie dormant in the soil, waiting to infect the next generation. Okay, my friends, on that note, the screaming of the cicadas and my Aunt Kathy in Wisconsin will bring this episode to an end. Thank you as always for listening. Leave a like or a comment and subscribe to the podcast, please. If you want to provide a bit of financial support too, that would be wonderful. There are several ways you can help me out. First, consider becoming a patron. All the information on becoming a patron can be found at patreon.com/dispatches from the forest. Subscriptions start at just $5 a month. You can also make a donation via PayPal. My PayPal address is dispatchesfromtheforest@gmail.com. That's also, obviously, my email address, which you can use to send me any questions, comments, or suggestions for future episodes. And there's also merch. Check out the merch store and all it has to offer at cafepress.com/dispatches from the forest. I'm your host, Tim the Nature Nerd O'Hara, reminding you to go outside and get dirty. The Dispatches from the Forest podcast is a production of Dispatches from the Forest and may not be used or rebroadcast whole or in part without express written permission.